This screencast is to go over two of the problems from the comparing and scaling unit test that was given. And the two problems that people struggle with the most were most of the percent problems. So I wanted to go over two of these problems. And I'm going to go over numbers 9 and 10 because they are both percent problems, but they're solved slightly differently. They're a little bit different in their way of interpretation. But let's start with number 9. Sylvia hiked a 30-mile trail in 3 days. The first day she hiked 50% of the total distance. I know it's a percent problem because it has the word percent in it. And I know in a percent problem, whatever comes after the word of is the 100%. That's your total. So when I set this up, it says what distance is left after the first day. Well, I should probably figure out what distance she walked on the first day. So I'm going to solve this using percent bars. 100% goes here, and this is 0%. So I'm going to find that 50%. So what number is 100%? Well, it's 50% of the total distance. So what is the total distance? It's 30 miles. So 30 miles goes here, and I'm going to find a scale factor and draw my arrows towards what I don't know to find the scale factor. 50 divided by 100. My scale factor is 0.5. And then multiply by 0.5 and I get 15. So this 15 miles is 50% of the distance. So on the first day, she walked 15 miles on the first day. That means that if there were 30 miles to start with and she already walked 15 miles, there are 15 miles remaining. Now that makes sense, that the number that she walked and what remains is the same number because it was half, 50%. But the reason why I said it that way is because when you come down to part B, it says the second day she hiked 25% of the distance that remained. Remember we said that whatever comes after the word of is the total. So now the 100% is the distance that remained. And the distance that remained is 15 miles. There's 15 miles left for her to hike. So when I set up my percent bar, this time 100%, and I'm going down to 25%. This time 100% isn't 30. The 100% is the 15 miles that are left over. So I'm going to draw my arrow to what I don't know. I put 25 in the calculator first, divided by 100. My scale factor is times 0.25. And when I do that, I get 3.75 miles. Now, 25% is 3.75 miles. And 25% is what she hiked on the second day. So here is your answer. That on the second day, she hiked 375 miles. So if on the first day, she hiked 15 miles, and on the second day, she hiked 3.75 miles, then what did she have to hike on the third day so that what are they supposed to equal? When you add these three things up, they're supposed to equal 30 miles. So when I add these two together, I get 18.75 miles. And I'm going to subtract that from 30. And that means that the distance she walked on the third day was 11.25 miles on the third day. Or you could have taken the 3.75 and subtracted it from the 15 that was left over. So here are the three answers then from number 9. As for number 10 is a discount problem. Tyler wants a pair of shoes that sells for $60. He uses 2 coupons when he buys these shoes. One coupon is for 30% discount, and the other coupon is for $10 off. The 30% discount is 30% of the cost. So remember, that's 30% of the cost of the shoes. So that means the total is the 60. So when I set this up, this 100% is the cost for the shoes, and 0% is down here. This is 30%. Now the 100% is the cost for the shoes, so that's $60. And I'm trying to find this. The 30% is the discount. One coupon is for 30% discount. So the 30% is the discount. I'm going to label that. Keep saying it over and over again. Let's just label it. So I'm going to draw my arrows toward I don't know. I put the 30 in the calculator first, divided by 100. Scale factors times 0.3. When I do 0.3 times 60, I get $18. Now some of you are looking at your paper now saying, I already had $18. Yes, a lot of people got $18, but what they didn't realize is $18 is the discount. That's not what you pay for the shoes. With a discount, you have to take that off the price. So I have to do $60 minus the $18 discount, and you get $42. So with the discount, you'd only pay $42 for the shoes. But you have an additional discount of $10 off. So now how do I take $10 off? I just subtract it. Money minus money equals money. So $42 minus $10 discount. The final cost of the shoes with the 2 coupons is $32. The second part of this problem is asking you, what if you inverted it? What if instead you subtracted the $10 first and then took the 30% discount off what was left? Would you get the same answer? Well, let's see. If I first take the $60 and subtract the $10 coupon first, I would get $50 for the shoes. Now I'm going to apply the 30% discount to this new total. So when I set up my percent bars, the 100% is now the $50, because that's what I'm taking 30% of, because I'm doing it in the opposite order. So I'm going to take 30% of that, draw my arrows, but I don't know. When I find this 30%, that's not going to be the answer, that's just going to be the discount. Remember, the 30% is the discount. So 30 divided by 100 times 0.3, and I get $15. Now again, some of you are saying, that was my answer, but that's not the final answer, that's just the discount. And I'm going to take that discount off of the 50. Because I already took the $10 off, now I have to take the 30% off in money, and I get $35. So notice that when you do 30% off first, and then take $10 off, that's actually a better price than taking the $10 off first, because you're finding a percent of a smaller number, and that's why. That's why if you go to most stores, they will actually do it this way, because this way, this is a higher price. So would it be different? Yes, it'll be different, because the second way is a higher price. All right, I hope that going over those two with you helped you to understand how to do the problems. And I would like you to do some practice before you do your retake. Thanks.